Good afternoon. Thank you for the introduction, Hubert, and thank you everybody for the opportunity to address you this afternoon. I worked in the circuits industry in consumables and equipment for about the first 15 odd years of my career. And then within the same company, which got then called Coates, I was changed over to a new emerging market, industrial inkjet printing. So after 2 decades in that, I've in recent months have re-emerged blinking back into the world of printed circuit boards. It's been fascinating. Insofar as quite a bit has changed, but it's amazing how much hasn't changed. In some of the factories I've visited, I've seen machinery which is decades old, curtain coaters, screen printers that were probably built when I was a boy. Don't ask any questions. And so it is really, it's nice to see stuff evolve, but it's also nice to see stuff that you're very familiar with and it really can't be bettered. However, what has come together in that time is the fact that circuits have evolved, inkjet has evolved. And when I was in the inkjet industry, started in graphics, as it was said, and through that growth, we've seen improvement in inks, improvement in industrial printhead technology, we've seen improvement in printers, software, to get to the stage where we can now confidently see inkjet printers capable of printing solder mask. So, Notion Systems, very briefly, were dedicated basically to manufacturing of 3D printers, high accuracy 3D printers. Yes, we make printers for other applications, such as high accuracy 3D printing, printing of 3D items such as lenses for reading glasses and prescription glasses, also for sensors, for printing OLEDs, to make display screens from as small as your phone to the biggest screens you can think of. But we also make this baby here, which is for printing solder mask. So that's what the name of the game is. It can also print legend. We'll come back to that later on. I think you've probably had a bit of this yesterday. I have to make no apologies for repeating it, but it's a very valid point. With the current process of solder mask application, you have all those stages of applying it, drying it, then applying the film, photo mask, exposing, developing and stripping. And of course, what you've seen before, and it's still very true, is that inkjet printing the solder mask reduces it to just 2 steps with a lot of ancillary benefits. So you've taken out 5 steps in the process, but you've also taken out quite a lot more. There's a lot of work, there's a lot of space, there's a lot of cost. So at a conservative figure, looking at the reduction in manpower, the reduction in power consumption, the reduction in materials, we reckon it's 124,000 a year at least. And I won't go through all of this, the details, but the important point to make is that yes, there's less process steps. You only print where it's required. And it's a fundamental difference about inkjet printing, additive printing, is that you're only putting it where you need it. You're not applying it and stripping it off afterwards. So it is an additive, not a subtractive process. That means also we can avoid putting mask in the holes, mask in the pads, no satellites. I'll explain how that's avoided later on. You can repeat the same pattern over and over again if you want, but the whole point about inkjet is that you don't need to change the artwork, the photo tool, every time you want a difference in design. You do it in the software, and you can actually do it print by print if you want. I'll come back to my example of the prescription glasses. The 2 lenses need necessarily be the same. For inkjet, that's not a problem. You can vary the thickness across the same board. You'll see how that works later on. The dams can be smaller with more reliability and better adhesion. Resolution can be what you want it to be, more or less. And then, of course, the ones that I mentioned before, but taking out all those factors in the process. So here's the key difference. With the standard process of subtractive printing, you get an inverted wedge, if you like. And of course, there's the danger of entrapment underneath the undercut. So when you look at this figure here, it's completely the opposite. You're printing from the base up, and you're printing essentially a dome or a bump. And what that does is it essentially improves your adhesion, because you're not doing any chemical treatment afterwards that would damage it. You have the footprint at the base is wider, hence better adhesion. It's locally adaptable. By that I mean that if you want to have a different height across a panel or a board to accommodate where the particular components are going to be, you can do that. It's just built into the program. Comes back to the core message I'm saying here, which is that the whole process is different. So that the way the files are generated is different and when you design the program. But it's all aimed at being to get all these advantages, if you like. So you can have it as close to university flat. Alternatively, you can do 3D structures. You can build up, of course it would take a number of passes to do this, but you can build up the image to as high as you want. And therefore, you could actually skip legend by using 3D printing to form your serial numbers, lot numbers, QR codes, barcodes, all without any additional steps there'd be additional printing steps, admittedly, but no other processes to be taken into consideration. And here's one of the key things. The way that we hold the board in place, we'll see in a minute how we do it under this short video, but once we've read the fiducials, read the board, know exactly where everything is, the way the board is held in place is by using vacuum. That means that we can move the print head, the print assembly, closer to the board because there are no clamps at the side which would restrict the movement of, in this case, as you'll see, it's actually the base, the print stage that moves, in this case, not the print heads. So it means that because they would overlap, a clamp will cause a problem. You need to have a greater distance between the head. Well, it's called the throw distance. What that means is that there's less chance of any satellites forming. The other thing is that we have a patented blocker here to stop any possible danger of UV light reflecting off the copper and back up to the printhead, which wouldn't be good for the ink, but because it's closer, that's much negated. It also means less chance of any airflow. Vacuum holding the panel in place. And in this case, the print assembly stays in one place, stays steady. The stage goes back and forth. It takes some 38 seconds to print one side of a 610 by 610 panel. And then print done. If that was the end of the print run, the print assembly will go off to the service station, which is where, if it's been held for a long time, we would purge some of the ink out and then let the print heads rest on a vacuum bed where it's free from any dust or stray light. The print heads can be easily replaced. We supply them in a pre-assembled form, whereby it's quite simply a case of slide in, slide out, and there's a quick nozzle pattern printing to get the alignment correct. And that takes about 30 minutes or so, and then you're back running again. The heads, by the way, in this printer we use, Notion use a variety of different print heads, where there are about 8 or 9 worldwide manufacturers of production piezo print heads. We use Konica Minolta 1024 heads in this one, which are very reliable and ideal for the application, with a choice of solder mask inks as well. There's an idea of the sort of definition we get around the pads. That silver line there is reflection from the microscope light, by the way. And another feature is that, coming from an ink background, I know that if you want to change the finish of a solder mask, you've got to use a different ink formulation. Normally you have no choice. In this case, that's a panel printed with the same ink, in the same print pass, to get different levels of gloss or matte as desired. So you can vary the gloss levels across the panel. That's the, well, basically you refer to that later on, but that's the summary of the machine. The access is all at the front, so you don't have to climb into it to do the servicing. This is the print stage. If it's manually supplied, I'll come on to robotics in a minute. And yes, it's 3.5 tons, but then it's based on a granite base sitting on air bearings. The accuracy and repeatability plus or minus 2 microns. We do, the standard print substrate is 610 by 610, but we do make machines to order. So we're completing a machine which is 610 by 740, I think it is at the moment, for a specialist PCB application. And they can be even larger. So as I said, the conic Minolta print head, reservoir size can be what you want it to be. We can adjust the heads easily. We're getting close to a summary of it now. For the standard printer, we would use 9 print heads, which will cover the width of a 610 panel. And then 2 print heads can also be used if you want to have Legend in the same machine. By the way, one thing about that, because the solder mask is dried as it is printed, it's touch dry, so there's no problems in handling a freshly wet panel, as everybody who does this knows. Can be a bit of a nightmare. So they're touch dry, can be handled immediately afterwards, can also be immediately printed with Legend. You can then leave the final thermal and UV cure stages until the very end, and the solder mask and the Legend could be done together. I've mentioned about the capping station. The alignment is micron accuracy, and the files that we use, those formats. And as I say, they would be raised in a different way, but we would educate people on how to do that, for samplings, for example. So in summary, less process steps, you only put the ink where it's wanted, it's a much smaller floor space, less maintenance costs and downtime. Basically, for inkjet printing, a happy inkjet head is a printing inkjet head. So the more it's used, the happier it is. If it isn't in use, heads sit in storage and they're ready to go again because there's no evaporation solvents in the UV solder mask formulations. No mask in the holes or on the pads. We mentioned the floor space, and environmentally more friendly because you're using a lot less chemicals, including less solder mask. You can also use robots for loading and or unloading. Another quick video if I can. Those are the 3 ink supply tanks. There's 1 ink tank per 3 heads. That's a line in the panel before printing, and then off it goes. Except... And of course, with 2 print machines, you could do 1 side per machine transfer over. Or flip it over and do 2 sides of the 1 machine. Right, that's me done. I just want to say thank you to Frank Tinnenfeld, who kindly gave me a speaking slot. He's from ASS, who are our distributors for a lot of Europe. So thank you very much for your time.